Hey and welcome. Today we are going to solve product of array except self-interview questions, so let's get into it. Here we have the first example. As you can see, at each index, all the numbers are multiplied together except the value in that specific index. Let me show you. 24 comes from multiplication of 2 by 3 by 4. 12 comes from 1 by 3 by 4. Same story for 8. And finally, same for 6 again. And that is how we might build our output array. Second example, same story goes here as well. It just tries to give us two hints. Number one, values could be negative. Number two, what I like to call the zero power. As you can see, if we have a zero, the only possible non-zero value we could get in resulted array would be for where the zero element exists, because all other cases will be cancelled out by zero multiplication. Let's see how we are going to solve this problem. The easy way we can think about would be to get the overall product of array first, then divide it in every index by the value of that index from original array. But this problem is not asking for that simple solution. There's a trick for solving this problem and it will cost us some extra space. The solution is we can have two arrays that every index will hold product results of everything before itself, but in two directions. Once iterating the original array from left and once iterating it from right. Those two arrays will come to help us in our final iteration in a way that at every index we can directly access the product results to the left and right of the number we have in our hand simultaneously. And of course, if we multiply those two numbers together, we will get the product of array except for the index that we are iterating. That is the secret sauce for this problem. But there are some stuff that I need to mention first. First is how we are going to build these product arrays. For each of these arrays, the first index will be 1. Why? Because when we are at the first indices, we don't have anything to the left or right of the array. So technically, we should put 0 as a first element. But we are going to multiply things together. If we have zeros at any index, it will cancel out all values after them. The same situation we saw with example 2 earlier. So we will put 1 because it has a neutral effect in terms of multiplication. The second thing is super simple. When we are building these product arrays, in every index, we don't need to go back until beginning index of that direction, then multiply everything up to the index we are. Remember that every item from that product's array is already the result of everything before them. So for every new indices, we will take that previous item and multiply it with the value that sits in previous index from original array to get the multiplication result for everything before the index we are. And this cycle will continue for the other array as well to build the products from that directions once more. The last thing is this solution will cost us some space. So we need to think about how we can reduce this damage and label it as a space optimization. Well, of course, in this type of questions, the result array that we are going to build will not be counted in space calculations because they expect us to return some array in result. But we kind of rely in these two product arrays values from both. So can we do it better? The answer is yes. What we are missing here is just what if we build a result array as we go through the algorithm? I mean, initially we can fill the result array with product values starting from left, but when we are doing a reverse traversal from right side, we can update its value once more. But this time, remember that 1 we put in the beginning? Now we will keep it as a right coefficient. So what's going to happen next? Well, we will do our iteration from right, but each time, whatever we have in our result array at our iteration index will be multiplied to that coefficient, and it will replace that value in result array. Then we might update the coefficient by multiplying it to the value from original array at that index that we are currently. Now, if we finish the iteration, look just what is going to happen. We will have our result array, and that will work for us because each iteration in our algorithm will contribute its own part to the result array, and it will make the space guy happy at the end. Okay, let's jump into the code to implement it. For non-space optimized solution, initially we will store the length of the given nums array in a variable because it will be used so many times. Then we will create our arrays for both left and right traversals. Now, as we discussed before, we will put 1 as first element to the beginning index of our iterations. So for the left array, it will be the first index, and for the right array, it will be the last index in array. Now it's time to build our left array with those product values. So in every iteration, we will multiply previous value from left array to the previous value from original array. We will start our iteration from second index. That is why I is equal to 1, because we manually filled the index 0 with 1 in line 10 here. Next up is the same story for right array, but this time we will iterate from end of the array, and remember that we initially put 1 to the last index. So we might start from n-2 index and iterate down to the index 0. Now we are almost done. we just need to create a result array, and in our last iteration, we might leverage that index of iteration to access both products from left and right array at the same time and multiply them together to fill the result array at the index of iteration. And after doing that, we return the result array. Now, if I run this, test cases are passing, and if I submit, we are in a good shape here. Now let's implement the space-optimized solution. Okay, for this, again, initially, we will store length of the array in a variable because it is useful, plus initiate our result array. Well, as you might remember, we will first fill the result array with product values that would represent the same left array from previous implementation. But this time, it's directly going to be stored in a result array. Okay, things will be interesting afterwards. There is no right array, so we will keep our coefficient initially as 1. Then, iteration from end of the result array is our next step. Within this iteration, first we will calculate the product for the current index we have using our coefficient, and then update the coefficient value by multiplying it with the number at iteration index from original array. At this step, after our last iteration, the result array is baked and ready to be returned. Now if I run this, test cases are passing, and if I submit, we are in a good shape here. Now let's jump into the slides for time and space complexity analysis. So the time complexity will be O of n for first solution. Actually, it will be O of 3n, in which the constant values does not count, so it will end up in O of n. You might ask why 3, because we did 3 iteration over the length of nums array. And it's the same for second solution. It will be O of 2n, which will eventually count as O of n. The space complexity will be O of 2n, which will result in O of n, again, for the first solution, and then O of 1 constant after our optimization work, because we built our result array incrementally through our iteration. So that was it for this video. Thanks for watching, and please leave a like, comment, and subscribe to the channel. I will put a few more links about different playlists in the description for you to check it out. And finally, hope you enjoyed this video and stay tuned for the next one.